Hi, I'm Jerry, and the social issue I aim to address is climate change. Climate change is an issue that disproportionately affects low-income and developing nations who often have fewer resources to prepare, recover, and relocate. This is why I have decided to create my project, DewDrop. The DewDrop is a cheap and accessible IoT-based weather station that aims to serve as an early detection system for extreme weather events, such as heat waves and flash floods within remote or vulnerable communities. DewDrop has three notable features. First of all, you might notice that there is actually a solar panel. This solar panel is enough to sustain its power draw for an entire day and night cycle. This, combined with a 5-volt USP, which has not been integrated yet, will allow these weather stations to be deployed in vastly remote areas with little to no management required. A notable feature is actually a moisture sensor with a funnel that effectively turns any subtle rain into information that can be captured and sent to our receivers. The last feature is a BMP 180 sensor that will detect pressure as well as temperature. This will allow the server to calculate whether the pressure is rising or falling to predict thunderstorms and also provide feedback to the temperature. Alright, so for the actual demo, as you can see, the ESP32 LoRa module is currently displaying the room temperature, the current pressure, and also the moisture sensor. All this data is being sent periodically to the receiver. As you can see on the receiver, you can see the signal strength. It's basically near perfect. There's all of the metrics, the temperature, pressure, as well as the moisture. And finally, on the web dashboard, as you can see, it is 26.3 degrees Celsius inside, but the weather is stormy. And in fact, in my weather app on my phone, it currently says it is light rain in the vicinity. I'd also like to address some flaws that I would like to fix in the future. First of all, this LED, while it looks bright indoors, is actually very dim outdoors. So I would like to address this with a more robust power system as well as a brighter LED in the future. As you can see in the mount is not held very securely and is actually pressure fit with mesh. So in the future, I would 3D print new adapters for different pole sizes or just use a better pole in the future. Finally, this solar panel mount is hung by just a few wires. So in the future, I would build an actual mount and perhaps use a more robust and compatible solar panel for this project. I believe that the DewDrop is one of the best ways to scale early detection of weather events in remote areas due to its modularity and accessibility. All in all, this was a very fun project to make. And I thank you for watching.